Hi U10s. In this video I'm going to be going through negative indices and talk about how that relates to division, and not that it's a negative number. That's the most important thing. And how to rewrite expressions involving negative indices with positive indices and applying our index laws involving negative indices. Okay, so that's what are we doing? But to start us off, I wanted to get to show you, basically, we're looking at the powers of 2. Now, 2 to the power of 6, 2 times 2 times 2 times 2, etc., is 2 to the power of 6, which is 64. 2 to the power of 5 is 32. 2 to the power of 4 is 16. Let's keep working our way down. 2 to the power of 3 is 8. 2 squared is 4. 2 to the power of 1. Now, if I'm going, what you should notice is I'm going down by 1 as I go across here with the powers. So now 2 to the power of 0, well, hopefully you can recall that anything to the power of 0 is 1. Well, what goes in here? Well, we've got 2 to the power of negative 1. So let's do this. So we're going 2 to the power of 5. 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, so it's the same, 2 to the power of 0. Now, as I'm going across, 2 to the power of negative 1 is actually 1 on 2. But how would we, so in terms of positive indices, 1 over 2 can be expressed as 1 over 2 to the power of 1. So these two are the same. So 2 to the power of negative 1 is equal to 1 over 2 to the power of 1. So let's have a look though. What is 2 to the, let's show you another way. What is, we also know that 1 is 2 to the power of 0. So if I had 2 to the power of 0 over 2 to the power of 1, how does that equal this thing? Well, if I subtract one from the other, if I subtract 2 to the power of 0, take away 1, remember our index law 2, we're subtracting the power of the denominator with the same base, and we've got 2 to the power of negative 1. So 2 to the power of negative 1 is not a negative number, it's actually 1 over 2 to the power of 1. Okay, 1 over 2 to the power of 1 is 2 to the power of negative 1. 1 over 2 to the power of 2 is, hopefully, can you see the pattern there? Can you see the pattern there? Let's have a look. 1 over 2 to the power of, so 1 over 2 to the power of 2 is 2 to the power of negative 2. Let's do this. 1 over 8 is 1 over 2 to the power of 3, which is 2 to the power of negative 3. That brings us on to the theory that that a to the power of minus m is 1 over a to the power of m. And likewise, if I was to do 1 divided by a negative power, then that's also can be a positive. So if I did, let's do 1 over, if I said 1 over 2 to the power of negative 3, then using this, our sort of law, for negative indices is 2 to the power of 3. In other words, you can make it positive by changing it and moving it to the numerator. And likewise, we can make it positive by moving a negative from the top to the bottom, if you like. Okay, let's do some examples. Express as positive indices. You're going to see this a lot now. When it says express, it's going to say simplify as positive indices. So we've got b to the power of minus 4 is equal to 1 over b to the power of 4. Okay, that's using this guy over here. Now, likewise, though, remember that we can move negative powers to the bottom of a fraction, but positive powers can stay the same, and same with the numbers. So over here, we've got 3. Well, the x to the power of minus 4 can go on the bottom as expressed as a positive indice, and we can leave 3 and y squared. They don't move anywhere. Okay, numbers don't move anywhere. If numbers on the bottom of a fraction, it stays there. Okay, but with these negative powers, notice the negative power, negative x, we were looking at x to the negative 4, that is going on the bottom. Likewise, we've got 5x to the power of, think about it, that's the same. If I was to split it up, we've got 5 times 1 over x minus 3. Well, how do we change this to a positive power? Well, we move the x to the top and change the power to positive. Okay, so hopefully if we try some more, that's going to be b to the power of 1 over b to the power of 3 is the same as b to the power of minus 3. Again, I will say, if I was to have this, b to the power of 0 over b to the power of 3, then we know that we're subtracting 3 from 0, b 0 minus 3, because we know that b to the power of 0 is 1, isn't it? So that is this thing here. Okay, and as you can see, 3 taken away from 0 is minus 3, which is what we started with. Okay, so another way to write these, and again, positive indices. Again, what are we doing? The 2 stays there. The y cubed is positive power, so we leave that, but the squared goes on the bottom, doesn't it? And likewise, if a negative is on the bottom, we can make it positive by moving it to the top. Okay, I guess these in isolation aren't so bad, but it's when you've got to bring them all together with other ones. So let's have a look at some examples here using index laws with negative indices. Okay, so now we know, hopefully, that law 1, law 2, well, law 2 is when we've got indices of the same base and we're dividing. So we're going down here. Let's do this. So we're going to apply that law first. And then, if there's any negative indices, we need to turn them into positive ones. So we've got 2 stays out the front. A cubed on a to the power of 5. Well, let's do that. 3 take away 5 is what we're doing. And 2 and 3, b 2 take away 3. I won't do a fraction yet, okay, but what that's going to mean is we've got, well, 3 take away 5 is negative 2, isn't it? And 2 take away 3 is negative 1. Well, we don't want to express it like this because we can simplify by expressing as positive indices, which means that these negative indices can become positive when we have them on the bottom. I technically won't write b to the power of 1 because in fact in algebra we just write b, don't we? And that's done. Now let's do this again. Try to simplify the numbers when you can. So first of all, I'm going to write the whole thing. And if we're expressing these, we need to collect indices of the same base. So clearly we've got m's and n's. Okay, so the m's, we need to collect those together. This time though, notice we've got a negative on the top. That's okay. I don't want you to move it to the bottom yet. You could, and if you could, it would be n squared, and then you would have, m squared. And then if you had m squared times m5 to the power of 5 on the bottom, you would have m to the power of 7. You could do that, but let me show you another way to do that. So we've got 4 eighths. Now, first of all, I'm going to divide the top by 4 and the bottom by 4. Do this one step at a time, which is, we know is like a half. 4 eighths is a half. So a half, we're going to have a 2 on the bottom, and we are a 1 on the top if you like, but that's not necessary. Minus 2 minus 5. Minus 2 minus 5 is minus 7 when applying those things highlighted. N to the power of 3. Let's do this a long way. Let's go through 3. We're subtracting negative 4. You've got to be very careful here because of this sort of double negative. All right. Now that's going to be, what have we got? I'm not going to write 1 anymore. We'll write m to the power of minus 7. 3 minus minus 4 is 3 plus 4, which is 7. Okay, and then that's over 2. And you can see there we want positive indices, don't we? Which means that we've got anything with a negative power can go on the bottom. Don't forget that the 2 stays there. And there you go, we are done. That is our final answer with positive indices or positive powers. Indices and power, same thing. Okay, now I'm going to get you to try this one. Again, apply your laws. We've got law 2 where we're dividing two indices of the same base. Remember, we subtract the power. We're subtracting the denominator. Have a go at this one, please, and I'll go through my answers shortly. All right, now here's my answers for these. Now, again, I don't want you to write answers because I want you to write your working. Now, first of all, we're applying law 2, which, I don't know what happened there. We're applying law 2, which means that we're subtracting 4 from 2 for A, and we're subtracting 7 from 3. That gives us A to the power of minus 2, B to the power of minus 4. But we want positive indices, so we're getting those on the bottom. Notice that the 5 stays there. Okay, and this one here, first of all, I divided by 3 because I wanted to deal with the numbers first. 3/9 is 1/3. Notice there that the 3 on the bottom indicates that's 1/3. Okay, now we're subtracting 4 from -3 for m, which is law 2, which gives us m to the power of minus 7. We're subtracting -2 from 6 because, again, we're subtracting that power on the bottom. So 6 subtract -2 is positive 8. That stays there because it is negative. Sorry, because it's positive. And the m to the power of minus 7 goes on the bottom as a positive power. The 3 stays the same. I hope that makes sense. You do definitely need to practice these for sure. Now, there's a couple here that I'll go through. This first one I'm going to go through in its entirety, and I'm going to give you a chance to practice something very similar. Okay, so hopefully we can recognize that when we've got indices, I did notice a few people when I was looking at some coursework, they were doing things like this. Let's say p squared, and I had something, q to the power of 5. I noticed this a little bit. When we've got indices inside a bracket, we multiply the powers. And I did things like some students did p, they did like 2 to the power of 3 is 8. Well, we're multiplying the powers here. 2 times 3 is 6 in this case. So what we're doing is we're multiplying the powers. So let's do that first for this one. That's going to be p to the power of minus 8, q to the power of 4. 1 times 4 is 4. That's multiplying. -2 times -3 is positive 6. And I'm going to do this, and we're just going to work our way across. So on the bottom there's not much to do yet. We're going to work our way across. Now that's going to be q to the power of 3 to the power of -3. We're just multiplying the powers. Q to the power of -9. That looks like a 9, doesn't it? It's a q. Okay, so let's work our way across now. Now you can work your way down if you like. I just always like to work across and then down. And it's not a bad way to go. It's usually just a bit easier, and you usually have to deal with less negatives. It usually takes me less time doing it this way. So I hope that you do the same, but you don't have to. If you want to go down, work your way down and then across, you can as well. Okay, so working our way across, we know that two indices are the same base. When we're multiplying them, we add the powers, don't we? So -8 plus 6 is -2. Then I've got q to the power of 4. That's on top. And let's do on the bottom. 5 stays there. Q to the power of 3 times q to the power of -9. We're adding the powers. 3 take 9 is -6. Okay, now let's do, now that we've gone across, now we've got a P on the top and the bottom, Q on the top and the bottom, just one singular P and one singular Q. So now let's apply this, which means that we've got to look at the powers and we've got to subtract. We are subtracting -1 from -2. We're subtracting -6 from 4. Don't forget the numbers stay at the bottom. So we're looking at p minus 2. Probably best to write it out like this. We're subtracting -1. These negatives, these double negatives, can really throw people off. So I think that you are best to write it like this rather than just missing it and skipping out on that step. Now, if I do that, -2 minus -1 is -2 plus 1. Okay, -2 plus 1 is -1. And 4 minus minus is +6, 4 plus 6, which means that we're looking at q to the power of 10. That's over 5, and of course we're not done yet because p to the power of -1 is a negative indice. We want a positive indice, so let's get it on the bottom. So I won't write p5. Technically, I see that a lot. Not even p to the power of 1, 5p on the bottom. Now, we also have seen before that if we've got a division sign, we can change division. So let's do that. But first of all, let's do inside the brackets first. Okay, so let's go inside the brackets, and we're going to do these separately. 2 to the power of 1 times 3. Well, that's going to be 1 times 3 is 3, so that's 2 to the power of 3, m to the power of 9, r to the power of 2 times 3 is 6, n to the power of -12. Then I've got divide, and now what I'm going to do is I'm going to calculate this bracket here. Now 5 squared is 25, or 5 to the power of 2. I'll leave that as 5 to the power of 2. M to the power of -2 times 2 is -4, and n to the power of 3 twos is 6. And then we've got r to the power of 2. Now, the reason why I've done that now is now that hopefully you can see, I'm going to rub that out for the time being so I have some room, is this divide can be a problem, but we can change this divide to hopefully you're saying we can change it to a times because it makes it easier. And by doing that, we can flip the divisor like so, which means that everything on the bottom, r squared in this case, is now on the top. And 5 squared, we're going to write 25, aren't we? Because this really can't simplify with anything else. Now, but be careful. I have moved this -4 from the top to the bottom. However, because I'm changing the divide to a times, I have to keep that power the same. Okay, so that can be confusing because we know that with index laws, negative powers can become positive when we move from the top to the bottom and vice versa. But this time we're changing that because we're changing a divide to a multiply. So I want to keep that negative as a negative on the bottom. That is a very common mistake. You will probably make it. That's okay. It is a misconception and it's easy. It's a very easy misconception. Let's do over here though, 8, and of course I would prefer you to work across because it does mean that you probably sometimes have to deal with less negatives and things, or subtracting negatives. So what we're going to do now is work our way across now. That's going to be nice and easy. M to the power of 9, r squared on top, and on bottom, what do we have? We've got r squared. That's r to the power of 6. We've got a 25, which we'll put out the front. And again, let's have a look. Well, m to the power of -4. And we've got an n here. N -12 and +6 is -6. I'm adding those two powers. So remember, here we're looking at quite a few index laws all in one go. Okay, so whenever we work our way across, here, that there is law 1, which is two indices of the same base multiplied. We add the powers. Okay, so -12 plus 6 is -6. Now what we can do is we can then work our way down, can't we? If we work our way down, then the numbers stay as they are. We can't simplify 8 and 25 as a fraction. But we can simplify r squared divided by r. 2 take away 1 is just 1. Okay, so that's just r squared divided by r is r, isn't it? 2 take away 1 is 1, so it would just be r. Now we've got m to the power of 9, take away -4. Okay, and likewise, we've got an n to the power of -6, which just doesn't go anywhere. That has to stay there for the time being, but hopefully you can see here we've got m to the power of, that's going to be 9 plus 4, which is 13, on 25. And don't forget, this negative power can become positive by putting it on the top. So it's n to the power of 6, and that's our answer. Now, I'm going to get you to try this last one. I'm going to leave this one up on the screen, though, so you can see it's very similar to these ones that you've got here. Okay, so can I get you to have a go at these? Now's the time to make the mistakes so we can learn from them. If you don't attempt something and you think that just by passively watching this, you're not going to get the same experience. The whole learning experience is we make mistakes, we learn from them. Hey, if you can get this first up, fantastic. Have a go at these and I'll reveal my answers shortly. All right, so let's go through that. That's a lot, and you will have to pause this along the way. And let me explain it first. Then I think you really need to jot down not just your answer. The answer is really not that important in this case because it's a process which gets you to the answer. All right, so first of all, we're multiplying the powers here. So 1 times 3 is -3, and 1 times 3 is 3. Of course, -2 times -1 is 2, and of course, 2 times -1 is -2, multiplying those powers. Then when we go, we go across, which means 2 and 3, -3 added together is -1. Q to the power of 3 just stays there when we go across. The 2 stays on the bottom, and of course, when I'm multiplying across, q to the power of 2 times q to the power of -2 is q to the power of 0, which hopefully you can recognize is 1. Now, when I go work my way down, -1 subtract -2, remember I'm subtracting this power from the 1 on the top, that's going to give me p to the power of 1. Q to the power of, well, 3 subtract 0 is 3, but also likewise, we also know that q to the power of 0 is 1, so I can also do that. And then finally, the 2 stays on the bottom and we're done. Over here, don't forget it's 2 to the power of 2, which is of course 4, but we can do that later. N to the power of 2 times 2 is 4, 4 times 2 is 8, and -3 times 2 is -6. I'm leaving the divide symbol and I'm going to work out the fraction. 4 to the power of 3, we'll deal with that later. We don't even need to simplify and work that out yet. As it turns out, m to the power of -3, multiplying those across. R to the power of 3, 1 times 3 is 3. Then we've got, we then want to work our way across, okay, and, anything that is on the bottom, we've got to change it to the top and vice versa because it makes our life easier when we're multiplying rather than dividing. Okay, so when we do that, we work our way across and we've got 2 squared is 4, and we've got m to the power of 4 are 3 to the power of 3 on top. On the bottom, I've got 4 to the power of 3 sort of out the front here. Makes more sense to have those numbers out the front. M to the power of -3, we're working our way across. N to the power of -6 times n to the power of 6. Add the powers, it's 0. And then r to the power of 8 was always there. So then what we've got to do is we've got to work our way down. So what we've got is 4 subtract 4 cubed is, well, 1 take 3 is -2. And of course, expressing that as a positive power is 1 over 4 squared. So those two numbers there become 4 squared on the bottom, or 4 to the power of -2 if it's on the top. We want positive powers, don't we? Okay, so I've done that step, and then we've got 4 subtract -3 for m, and 3 subtract 8 is, of course, 7 and -5, and we want the negative power to go on the bottom, don't we? So we have to move that and leave everything else where it is. I know that it's a lot. When we're looking at, when we're starting to combine the laws and do negatives, some of these can be quite tricky, and especially you will make sign errors, you'll make all sorts of errors, but the more you practice, the less errors you make, and you want to make those errors and learn from them. rather than just simply say, okay, well, yep, okay, made that mistake, I'll keep making it. We don't want to do that. All right, we'll need to try those questions, but more importantly, when you're going through these, I want you to take it one step at a time. I haven't got this working here just for fun. This working is so we can work through it logically. That's what we've got to do in maths to sort of make less and less mistakes. Work through it logically, and if you make some errors, we can go back and look at our logic. All right, thank you, and hope that that makes sense. I do think that you will have questions for this. Hopefully you come into class with questions. Thank you.